Hi, I'm Mike Coleman, a developer advocate here at Google Cloud, and in this video, I want to talk to you about how you manage your applications after you've migrated them using Migrate for Anthos. Getting your application containerized is just the first step. You'll also need to consider how you manage that application going forward. How do you handle base operating system updates, application patching, and other day 2 tasks? The rest of this video aims to answer some of those questions. As a quick side note, I'm not going to spend a lot of time talking about how container images are constructed. If you're not familiar with that topic, pause the video, go check out the documentation on the Docker site, and come back and rejoin me. Also, if you're not familiar with Migrate for Anthos, check out our earlier videos where we provide an overview of the service as well as how to perform an actual migration. You can find a link to those in the description below. With that being said, let's take a look at how Migrate for Anthos creates the container image for a migrated application. Migrate for Anthos automatically examines a source VM and extracts the workloads running there into their own container images. When looking at the ongoing management of those containers, it's important to understand how their images are actually built. The container that you run in production is a combination of 2 intermediate images. The first one is the Migrate for Anthos runtime layer, and the other is what we refer to as the non-runnable system layer. The non-runnable system layer contains the extracted portion of your migrated workloads and will serve as the base for all future updates. As the name implies, this layer by itself doesn't do anything. It's only by combining it with the Migrate for Anthos runtime layer that you get a container image that you can deploy into production. So let's look at the Docker file so you can see how this works in practice. Now, the Docker file uses a multi-stage build to combine the 2 artifacts together. This first from statement tells Docker to use the Migrate for Anthos 1.6.0 runtime image from the Google Container Registry and to refer to it going forward as quote-unquote Migrate for Anthos runtime. The next from tells the Docker file to use the image that was generated when you ran your migration. It's also stored up in the Google Container Registry under your project. Notice that Docker will refer to this image as quote-unquote source content. As an aside, while I am specifically using Google Container Registry in this example, depending on where you're migrating from, we can also use AWS's Elastic Container Registry or a local registry. This section is where you would run any updates, and we're going to cover that in more detail in the next section, so for now, we'll just skip over it. This line tells Docker to copy the file system starting at the root from the Migrate for Anthos runtime into the container image. Now remember that the container image we're copying into is the source content image. So basically, this command copies the runtime container image into the source content image. And the last line tells the container to run the v2k.go script and start your migrated application. Now, as I've said, this Docker file is what's used to create the migrated application configuration that you initially deploy after running Migrate for Anthos. But what do you do if down the road you need to update the image for some reason? For example, you need to install an updated dependency or patch your application or upgrade the underlying Migrate for Anthos runtime. Going back to our Docker file. Now, updating the Migrate for Anthos runtime is actually pretty simple. You just go back to that first from line and you update the version. If you need to update any part of your application, including system or language libraries or the application code itself, you would do that after the second from statement. So for instance, if I'm a Node developer, I might copy in a new package.json and run npm install to update some of the packages my application is using. Or I could copy in a new app.js file to update my actual application code. The underlying file system in the container is the same as what you had in your VM, so you would just update the files in their original locations. Now, from here, you could manually run Docker build to create an updated image, push that to GCR, and then roll out the new version of your application. But manually building the new container images could become tedious if you are regularly processing updates. A better approach is to use a tool like Cloud Build to automate the process with a modern CI/CD pipeline. By leveraging a tool like Cloud Build, you can define triggers such that whenever a change is pushed to your source code repository, a new container image is created. And once that new image is created, you can perform manual or automated tests. And then finally, using either manual or automated processes, you can push that code out into production. Let's take a look at how we would implement a pipeline in practice. I'm going to construct a simple pipeline that will connect to my GitHub repo such that when I push a new change to GitHub, a new container image will be pushed up to GCR. From there, I'll update my Kubernetes YAML and roll that updated app into production. Okay, so let's go ahead here. We're going to start in Cloud Build, and I want to show you the trigger that I built earlier. Remember, a trigger is something that can kick off via different processes. So we have a trigger here that when I push to a branch in my GitHub repo here to do Cloud Build, where I've installed the GitHub app for Cloud Build, when I hit the master branch with an update, it's going to go ahead and run a Docker file. And it's going to do that in the root of the repository, looking for a file called Docker file. And it's going to build us a new image that is tagged with the short SHA of the build process, right? So that'll be our unique tag. And then if we look down here below, what we can see is the actual Docker file build, or the Docker build command, where we're going to build that. And we're going to point to that Docker file that I just mentioned. So that's what's going to happen whenever I push a change to my repo. Now, this is the Docker file. We talked about this earlier in the video. You can see here is the runtime. Here is the non-runnable base that is created as part of the migration process. And then what I've added to it, if we come down here, is I'm basically saying copy the contents of this repo into user source to do in the container, right? In the container image. And that's where it was located in the VM. That's where the code was located in the container as well then. They're the same. So now what I want to do is I want to come up and I want to actually go ahead and make a change to my source code. So I'm going to come up here into this show task file here at the top. And I'm going to click here and I'm going to go in, and I'm not running these on VMs, so it's not a host, it's actually a pod. So let me change this to pod. And then I will save this file out, and then I will move down here into the terminal, and I'll do a git add star to add the changed file. I'll commit that to the repo with a commit message of use update host string, and then I'll go ahead and do a push. Now this push will kick off that trigger that we just talked about. So if I come into history, you can see it's already building. So we'll come in here, and I'll show you here in a second when this comes up. You can actually see there's that commit message I used, update host string. This is going to take a bit, so let me pause the video and I'll rejoin you when it's done. Okay, so we've finished up here, and if we come down, we can see there's where we copied the source code into the image, as I mentioned, and here's that short SHA, and we're going to use that to do the update to our application. So let's go to the image repository here, container registry, look at the images, and that's where the non-runnable base gets stored by the migration process, and there's the to-do directory. That is where we actually get our deployable applications. So there's the one we just created. And now we're going to deploy that by opening up a Cloud Shell and editing the Kubernetes YAML file. So let's open this up, and we're going to move into the directory where the artifacts are stored, and we're going to edit the deployment spec.yaml, and we're just going to scroll down here, and we're going to change that tag on the image name to the one we just created. We're going to save that out, and then we're going to go into the terminal, and we're going to go ahead and, well, before we do that, let me point this out. So it says served by host. That's what we're going to change. So now let me go here, and I want to go ahead and clear the screen. And then we'll do a kubectl apply -f deployment spec.yaml, and that's going to update the stateful set with a new image. Let's do a get pods with a watch so we can watch that happen. And while that's happening, I want to just talk about a couple of things. One, this is not exactly what you would do, right? There would be a step between building the image and deploying it. And that would involve some sort of testing, right? We talked about that. And the other thing is you could automate this step if you wanted to, right? In the video, we don't really have time to go through that process, but you could fully automate this. So you automate your testing, you automate the sign-offs and the release, and then you automate the push to production. Here, we're just basically automating the building of the container image. We're assuming a manual test step and a manual deployment step. All right, so we're almost done here. Container should be up and running in just a couple seconds. And looks like it's just about done. So let's go ahead and check on that application and see if our change got reflected. So we'll come up here, click on to-do list app, and you can see down here, actually there it is. It's now served by a pod instead of a host. So the application has been updated. So in this video, we talked about how you can use a cloud build trigger connected to a GitHub repo to automate the creation or the updating of your migrated applications. That about wraps it up for this video. I hope you found it useful. If you want more information on Migrate for Anthos, we have some additional videos posted here on YouTube, so check those out. And then head on over to cloud.google.com/migrate/Anthos to learn more.